Yeah, maybe if I try to do so, it's easy for me now to use a model which I use in my lecture. It's a 4-stage model, and it started with the invention of the computer. And during that time, we started to digitize everything. We tried to really describe the world with the help of our digital tools. So finally, we create some digital images of the reality. And after a while, starting in the 80s, last century, it was not good enough for us to only have digital images, so we started to virtualize everything. So we started to create digital models. So when we have an artifact, a real artifact, we try to model it in a way that we are able then to simulate everything with the help of that model. For example, we use it for digital factories to simulate material flow, or to simulate process flows, material flows in tools, for example. But we also started to virtualize functions. So hardware-based functions, which are embedded in hardware, these functions are now software-based, software-defined. Yeah? Think about your smartphone. Yeah? Your first mobile phones had real switches, yeah? And now we have these switches directly on the surface of the smartphone. So it's defined by software. And now with the 90s, with the invention of the internet, the next phase started, the connectivity phase. And this was more or less the beginning of Industry 4.0. So we started to connect everything. We used our digital descriptions, our models, and we started now, and also the software-defined functions, and we combined that now by connecting everything. So we created first the Internet of Things, and secondly, the industrial Internet of Things. And with the help of that connection, we are able to create completely new architectures, like cyber-physical systems. And cyber-physical systems, they have a physical part and a cyber part, and with the help of communication technology and platforms, we are now able to connect everything to one system architecture. And a good example is as well the smartphone. A lot of functionality on your smartphone is not really integrated in your smartphone. It's integrated in platforms somewhere in the internet, but you are able to access these functionalities with the help of your smartphone. And that means you have created a kind of cyber-physical system with physical functions and cyber functions. And maybe 15 years ago, we started with a phase of autonomization. So we use the data now we have in these systems in order to train algorithms and to create completely new systems. On one hand, at the beginning, so-called assistive systems, so systems which assist you, which helps you to make better decisions. And on the other hand, more and more autonomous systems, so technical systems which are able to make their own decisions, like self-driving cars, for example. And when you look now from the past till today, this was a real long phase of transformation. So step by step, with the help of these new software capabilities, with the new communication capabilities, with the new platforms, we started to transform the economy, starting with trading systems, for example, but also the mobile communication was completely transformed. And starting 10 years ago, we focused in Germany now very much on the transformation of industry. And that was the birth date of Industry 4.0, the fourth industrial revolution. In March 2020, we all moved all of a sudden into the home office and we started to work at home. And I think a few months before that date, nobody really were able to imagine that this is possible. So if you would have asked me 2 years ago if I think that it's possible that my institute moves completely into the home office and we see no gap in the performance, I would have said that will never happen. But now I'm convinced, because I've seen it, that it works. And I think that experience is an experience we share now with many companies worldwide. The situation helped us to improve or to accelerate in the digital transformation, and also to get more used to the different tools we can use in order to support different business processes. But what we have seen as well is that especially the companies who have already digitized their customer interface, their access to the customer, they had a huge advantage during that phase because they were able to develop their business as well being in the home office. But when you look at other companies who are not able or who were not able to digitize their access, they had a disadvantage in competition. And so that the digital champions, they really moved on, they accelerated their business development during that phase, and they also improved the value of their company. The digital beginners, the rookies, they really had an issue. And I think the gap between both become during that time bigger and bigger. And what this will mean to the development and to the value development of these companies, we will see in a few years. Maybe all of our customers here at the Fraunhofer IPA, they always say we have a lot of data. So it's not an issue. We have enough data. So just take the data and maybe you can help us to do a project with machine learning, with some processes of artificial intelligence in order to get the knowledge out of the data and to improve our processes. But it's not the amount of data. It's the data governance behind. It's the quality, it's the usability of the data, it's the accessibility of the data, and as well the know-how how to handle data and how to store data. And when you, for example, when you do a project, a machine learning project, and you have no data governance in place, around 80% of the whole time of the project is only focused on improving the data situation. The data you need for your algorithms which you want to train. And when you then want to scale that solution, so for example, you train an algorithm for one machine, and then you decided to roll out that algorithm on all the other maybe similar machines, often that does not work because the data governance is not clear and the data situation on each machine is different. So you have always these 80% of time to improve the data so that you can use the data for the machine learning algorithm. That means when you really want to be successful with your digital transformation, the first step is always data governance. You have to create a kind of digital shadow which you can use for your different systems, IT systems, which you can use to train, for example, machine learning algorithms. And the data governance is as well relevant for your data safety and security and also for your ongoing improvement of the data quality. Without the data governance concept and without investing money into the quality of your data, into the usability, availability of the data, the whole digital transformation will not really work in your company. Out of my point of view, the main focus should be on individualization or even on personalization. If we really want to compete in the future with our factories and our capabilities with the big online platforms, for example, the only way is to focus on highly personalized products. And we have to offer and deliver these products as fast as maybe your online platform is able to deliver their goods. On online platforms, you buy commodities usually, you buy standards, and these standard products are not personalized products. And when we in the industry now really focus not on make to stock, when we focus on engineer to order or design to order processes, and we are able to really digitize and automate the whole end-to-end process from the customer to the customer. This will really be a competitive edge and a target for the digital transformation. So if the customer is able on a platform to design his own product and he gets immediately an information about the delivery time, the price, and maybe there's as well a kind of dynamic pricing integrated. So if he accepts another configuration, he gets maybe a lower price, or if he wants to have the product faster, he has to pay a little bit more. That gives also us the possibility to improve our customer centricity. And then the customer orders, and the order is then moved automatically to all systems within seconds, and then we have the order directly on shop floor, and the shop floor starts immediately to produce the product the customer has designed and ordered. And during production, we use a fully flexible, very reconfigurable production situation. And then within hours, we produce the product, we pack it, and we send it to the customer. And that will, on one hand, bring the costs down because everything is automized, digitized, highly flexible, and reconfigurable on one hand. And on the other hand, we are able to compete with big online platforms, and we can create a kind of renaissance of the factory with the help of that approach. And we see already some examples in the market. For example, the company here close to Stuttgart, they were able to reduce the lead time from 4 days to 4 hours. And they deliver now 24 hours a day. And if somebody is able to order before 12 o'clock, the product will be shipped the same day to the customer. And at the beginning, when they started with the project, they had about 26 up to 30 employees in the whole process, as well a lot of indirect employees in doing the sales process, doing the planning and the engineering process. And after that transformation to a fully automated end-to-end engineer-to-order process, only 10 or 11 people are now left. Most of the people are direct workers in the factory, and all the indirect processes are fully automated. And then I think that is a vision for production, focusing on personalized products, on personalized solutions, and automating the whole back end, the whole end-to-end processes with the help of digital tools and the help of fully flexible production resources. The similarity is maybe that the digital transformation is relevant for all regions. There are no differences. But when you look at the different systemic situations, there are a lot of differences. When you go to the United States, you see a very market-oriented approach. A lot of capital, a lot of venture capital is in the market. The innovation speed is on a very high level. And the whole United States, they are software driven and very successful with their internet-based platforms like Amazon, Facebook, and. When you look at China, when you look at the East, you see that this market is a very controlled market. It's driven by the government with a long-term approach. The Chinese government, they try to develop China to the most important technology player worldwide. And they're investing as well a lot of money, and they have their 5 years plans in place, and they focus on highly relevant technologies, and they do everything to be the technology and the market leader in that field. And when you look at Europe, we are somehow in between. So we are a very saturated a region. For us, ethical aspects in data handling, for example, these aspects are very important. And so our opportunity maybe is to bring software and hardware together, maybe to bring into our development approaches ethical aspects. So ethics by design maybe is an approach we should keep in mind. And I think we are able to serve then both systems, the more market-driven system and the more state-driven system in China with these solutions, because finally when you look to the real aspects which are relevant for many people, I think ethical aspects in digital transformation will be highly relevant in the future for everybody worldwide. Yeah, the factory of the future maybe is an empty room. It's really an empty room with a very intelligent infrastructure, an intelligent floor, an intelligent ceiling, intelligent light, intelligent communication, 5G or 6G or 7G, we will see. And in this very intelligent room, there in that room we will find a lot of very flexible and reconfigurable and more autonomous production resources, like autonomous guided vehicles like HEVs. We will see many robots moving around, and also machines will be mobile and they were able to change their location. And then based on the production program, the whole shop floor will change, the whole layout will change. So the whole machines, they will move to different positions, all of the material will transport it automatically to the right position. And after the processing of an order, the production resources will immediately reconfigure themselves for the next order. So we will see a fully flexible system driven by different highly personalized customer orders, and the connectivity and the smartness of the systems, they will define finally the capability of a factory. And most factories, especially that's my expectation here in Europe and maybe in Germany, these factories will focus on engineer and design to order processes.